Okay, so today, as we mentioned before, we are going to talk about graphical user interface programming in Java. And as I said before many times, this is although graphical user interface programming is part of the Java programming language, it is basically a practice of using some predefined, nicely defined libraries. I don't consider it to be the core part of the Java programming language, but just to show you what kind of things we can do with object-oriented programming languages, what kind of things they are designing with this kind of tools, and what kind of libraries we can be customer of. This is a very good example. That's why I like to talk about this graphical user interface programming. Let's start. Okay, so as you know, the graphical user interfaces are just user interfaces. Usually we use these kind of terminal kind of user interfaces with our computers up to now. It gives us a command prompt, and with the command prompt, if I can get it, sorry. Yeah, I got the command prompt now. With the command prompt, we give commands like this, and it gives us results back. Sometimes the programs that we run asks for input. We type our input. It gives some results back. So it is all sequential. You do something, it does something. You do something, it does something. And you always know the sequence. The sequence is known. These are the terminal type user interfaces. With the graphical user interfaces, things are different. Why different? Because we have such an interface. For example, I have a window like that. On this window, there is nothing sequential. I can do anything that I want. I can click on one of these menu items. I can push one of these buttons. I can scroll down, scroll left, right. I can type things in here or choose this combo box, and I can minimize this thing. So I can do many things. It is up to me. So it is a little bit more involved than what I can do with the terminal. Okay, the terminal things are very simple. You do things and you print them out on the screen, and if you need input from the user, you wait for the input. You ask for the input, and user does whatever is needed. But with the graphical user interface programming, things are very different. User can do many things. So our regular scanf printf stuff doesn't work anymore. We have to be more we have to have more advanced programs to handle these kind of environments. That's why GUI is they spent lots of time to design these kind of interfaces to make the user experience better than the terminal type of user experience, and etc. So we are going to look at them. Okay, so that's what we are going to do. A user-friendly mechanism for interacting with an application. That's the basic definition of graphical user interface. And often it contains things that we know. For example, when you look at this, okay, you don't immediately go to the user's manual of this application. You just know that these are the menu items. You just the buttons, resizing it, minimizing it, and maximizing it, closing it, etc. You already know all of that stuff, so you recognize immediately what is going on with the graphical user interfaces. That's one of the nice things about them for the end users. Okay, so let's start our graphical user interface programming with a very simple example. Example is going to be this. When I run my program, I will ask for an integer to be entered, and the user will enter a number. for example 100, and they will hit OK. Then I will ask a second integer, they will enter another integer and they will hit OK, and I will show up a new window, and this new window will include this message: the sum is 123. That's what's going to be. Okay, so let's look at this one then. Okay, that's called addition. Okay, remember Java program name, class name, and the file name has to be the same for this public class. Okay, that's called addition. And with this addition, I am going to use this JOption pane class under this package. Okay, my main function. Okay, here it is. JOption pane class has a method named show input dialog. It's a static method, of course. Okay, this is the one, line 10 and 11. This is the one that shows this dialog. These are called dialogues in standard, okay, in standard graphical user interface terminology. These are called dialogues. Dialogues are special because when they pop up, you need to do whatever they want you to do. Okay, they ask you to enter an integer and you need to hit OK. If you don't do that, they will not go away. Okay, they will not go away. It's a pop-up window. It pops up and you need to do whatever. So it's called dialog. It's a special kind of window, but it's not a classical window. You need to perform an action and either hit OK or close cancel button. Okay, so this first number JOption pay show input dialog does that. Okay, so as you see, this one returns a string, not an integer. Of course, this show input dialog is, I mean, that's how it designed. It returns a string, okay, not an integer. So I get this as a string. I do the same thing for the second integer. I get another string. In order to be able to add these two integers contained in the string, I need to convert them to integers. This is how I would do that. Okay, I would say first number. Okay, I just parse it from string to integer. This is how you do that, and we did this before, if you remember, when we started the playing with Java first time. Integer, you remember this boxed version of int, fundamental type int. There is a parseint method. It takes a string and it parses it and it returns the integer for you. Okay, I got integer, I got the second integer. I add them up using the plus operator for the integers. Sum is the result now, and JOption pane has another, okay, has another static method. Its name is show message dialog. Okay, and its task is to print. Its task is to not to print. Its task is to show messages on the screen. Okay, so this one will pop up another window on the screen and it will show me the result. Okay, this one takes a number of parameters. I am not going to talk about this null for now. Later we will talk about it. This is the message that you like to print. Sum is plus sum, of course. Okay, tell me the type of this plus. What kind of operator is this? What kind of things does this plus work on? Anybody?
String concatenation.
Yeah, it works on the string, right? Exactly, it works on the string. It's string concatenation. Okay, but this is an integer, right? This is a string, this is an integer, and we said that in Java all the objects can be converted to strings using the toString method, but sum is not a regular object reference. Okay, sum is an integer, fundamental type. For the integers, for the ints, okay, for the ints like these, there is no toString method because they don't come from the same superclass object. Okay, What was the solution with Java for this problem? Autoboxing. Okay, so when you see an integer like this int, when you see an int like that, and Java trying to make this plus operational, I cannot add a string reference with an int, but I can convert this int to an integer, this integer, okay, with a capital I, boxed integer. And with the boxed integers, I have the toString method, okay. So this conversion from int to integer, integer to int, boxing and unboxing is done automatically in Java. Okay, that was one of the issues with the Java fundamental types. As we said before, Java fundamental types are there because we need to be efficient. We need to do doubles and integers and characters like the C programming language. But on the other hand, I like to be able to use the mechanisms of the object, right? I mean, toString method, clone method, equals method, and etc. So how am I gonna do those? Well, for those I have this boxed integer or boxed character or boxed double, etc. So this is what it's doing. So two things at the same time. Sum is boxed to produce an integer. From the integer using the toString method, I get a string, and this is a string concatenation operation. Okay, so the sum is this much is my string. This is the title of my window message dialog, and this is just a parameter. It says it's a plain message. So let's see what one. Okay, so this is the title of the window, sum of two integers. This is my message. This is okay, and this is a plain dialog. If you like to do other type of dialogues, like instead of plain dialog, okay, you could say it's an error message, information message, warning message, or question message, etc. So these are all documented. These are all documented in the show message dialog of the J option pane, show message dialog method, static method of the J option pane class. Okay, so very simple first example with the graphical user interfaces of Java. So let's move on to see other type of more realistic, more complicated graphical user interfaces. Usually this is what we're going to do. In this case, we used already defined window. Okay, it was the input dialog and the message dialog. Usually we make our own window types. We say that, okay, this is what we are going to do. We say that this is my window. I will have a text entry component at the top. I will have an OK button here, cancel button here, and I will have a text field like that. Okay, this is going to be a text field, and this text field has scroll bars. Okay, like that. These are my scroll bars, and you can, as I said before, you can add these kind of components one by one to your window. Usually, graphical user interface programming does that. It designs such a window. Okay, you add stuff like this one by one. Okay, and you tell the graphical user interface management system that if somebody presses this button, you are going to run this method. If somebody presses this button, you are going to run this method. If somebody enters a text here, you are going to run this method. If somebody scrolls these, and you are going to run this method, and etc. There are literally hundreds of things that you can do with a window. Okay, and for each action, you may specify a method, a callback method that will be called when that happens. And after that, you don't do anything. You just provide all these methods, and you are done. Okay. So the main loop of the system it works this way. So For now, we just use the already designed window, J option dialog, okay, message dialog option, okay. But now we will start making our own windows in a few minutes. Okay, let's look at the let's look at the let's look at our next program now. Actually, I'm going to show you the program first, and then okay. So that will be it. When I run this program, okay, it's not, I don't expect too much from it. When I run this program, it will show me 3 labels: label with text, label with text and icon, okay, and label with text and icon, and the text at the bottom, sorry. So 1, 2, 3 labels. These are called labels. Label means just the text, okay, and sometimes the text with an icon, some picture, etc. So I am going to tell the system that I will have this window of width 275 pixels, and here the height of 180 pixels. Okay, pixel is the smallest unit that can control on a screen. Okay, it could be a color. Okay, you would say that, okay, I have green color at this pixel, etc. So this will be 275 units wide. Each unit is a pixel length, okay, and this is the height. So you say this and you add 3 labels to it, and that's it. This program doesn't do much, okay. This program doesn't do much after that. Okay. That doesn't mean that we are going to keep working on this kind of stupid stuff. Let me show you what kind of things you are going to do at the end of today. Let me go to 160 maybe. Yeah, for example, just a paint program, simple paint program. You take your mouse and by dragging your mouse, you draw a picture like that. And the nice thing is that you can, when you resize this window, this picture is redrawn with the resized version, etc. Okay, so you can do this kind of stuff at the end of this lecture, and this is not a very long program. Actually, it is just 50 lines of code. It's not much. So let's go back and let's talk about this program again. Okay, so let me start from I will have 2 files. One of them is label frame, okay. This is the one that we are going to design as our window, and the other one is the one that contains the main method. Okay, it is the one that contains the main method. Let's look at this main method first. Okay, this one says that I am going to make a new label frame. Label frame is our new class. It is this window, okay, and I am going to set this default close operation to exit on close. So basically what I'm saying is that what happens if I click on this button? Okay, my behavior is set default close operation. My behavior is to close the window. Okay, so that's what I said. And then label frame set size, it's setting the size. I have this width and this height, and I am setting my window visible. It is visible now. Then weirdly, it's I mean, for us it is very weird actually. I end my program, okay. It looks like my program has ended. I just showed the window and it is gone. No, it doesn't happen that way. Once you set a window visible, Okay, true. Then this window will stay there. This window will stay there until somebody closes it by clicking this button, or the operating system kills it, etc. Okay, so that's what happens. But you might say, my program is ending here. How come this window can stay? This window has its own thread. Okay, another program is running parallel to my main, and that program, okay, subprogram, maybe a small program, a thread, okay, another process, you may call it at this phase. It still continues running, and the only way to stop that program from running is to close it, or sometimes operating system closes. For example, you go to the task manager, and with the task manager I have many processes running. You could, for example, I could go there and I could just, for example, end this task, right? I can end this task and it will be terminated. So operating system can terminate it, or I can terminate it by clicking this button. That's what happens. Okay, so this is how we are going to use our new window, our new label frame, and these are the stuff. These are the stuff that they are the methods of this label frame class. Okay, let's look at how I do my label frame class, which represents a window. Okay, this is our label frame. Okay, it extends JFrame. JFrame is the frame. Okay, remember what I said last time? This is a frame of a window. This frame has like these buttons. This is a close button, minimize, maximize, and there is a part of the window that is used for the resizing and etc. This is just a frame. Okay, inside the frame there is nothing. It is my task to add components to it. So I will add components to this frame. Okay, so I am saying that I am a JFrame. My name is label frame. I will extend JFrame with a number of additions. I will use 3 labels. JLabel is a component. Okay, remember, label is just as simple as a piece of text, or text plus icon, and etc. Okay, so these are the labels, and label frame is my constructor, of course. First thing I do is I call the constructor of the JFrame, okay, by doing this super testing JLabel. You remember this, right? You remember this. Question for you. In C++, we don't have a keyword named super. Can anybody tell me why we don't have a keyword named super? Why there is no keyword named super in C++? In Java, it is very convenient. This is how you call the constructor of the superclass, or in C++ terminology, constructor of the base class, right? In C++, we don't have this. In C++, instead of doing that, we say like this, right? JFrame testing label, etc. But in Java, we use super. Can anybody tell me why we don't have a keyword named super in C++? You can't have it because there is a problem, very serious problem with this keyword super.
Hocam, is it related to object class of Java?
No, not exactly, no.
Is it about the multiple inheritance?
Exactly, Emirhan. It is about multiple inheritance because in C++, right, we have multiple inheritance. So you may have more than one parent. In Java, there is a single parent only. So when you say super, it has to be JFrame. Okay? It cannot be anything other than JFrame. Okay? In C++, you may have more than one base class. When you say super, which one do you mean? Okay? That's why in C++ you have to specify your parent's name. Okay? I'm not saying that this is the reason, but that would have been a big problem if they decided to have a keyword named super in C++. Okay. So, as I said before designers of Java are very good C++ programmers. Okay. When they make a decision, it is not usually because they forget about it or they didn't know about that feature in C++. It is all intentional. Okay. That's why you can always ask the question, how come we don't have this in C++? Or how come they don't have it? They don't have this in Java, etc. Okay, so let's look at this Jlabel frame. First, I call the constructor of the JFrame because JFrame has to do lots of stuff like the open button, close button, minimize button, resize, and etc. It is all done here. Then I say that I have this flow layout. Flow layout this. Okay, set layout is this. When you start adding components to this window, okay, for example, an OK button, a text field that I can enter text like this, an icon here, a picture like that, okay. So how do I place these components one by one? This flow layout says that you are going to place them from left to right. Okay, you are going to place them from left to right. That's called flow layout. Okay, there are other types of layout strategies like the grid layout or the border layout or some other type of layouts. We are going to see them at the end of today's lecture. Okay, so this is called flow layout. Okay, so we said flow layout. I will make 3 labels, but these are not labels. These are not label references, of course. So to make a label, of course, I am going to use a new operator. New Jlabel, label with text. Okay. And then I set the tooltip text of the label. Tooltip is this. Tooltip is what? Tooltip is, can I have, okay, not that one. What kind? Okay, here is tooltip. When I come to an icon and I wait there without clicking, I get an explanation text. When I do this, okay, you see, okay, when I wait there, so these are tooltip. And in this case, if somebody goes over this icon and waits there, it says this is label 2. Okay, that's the tooltip. So I set the tooltip for label number 1 and I add this label, Jlabel, to this frame. Look at this one. Add is a method, right? Add is a method of what class? Who owns the method add? Anybody? Can anybody tell me who implements the method add? This is not a global method, right? There are no global methods in Java.
JFrame?
Exactly, JFrame. JFrame has the method add. Add is adding a component to my window. So I am saying that I am saying that I will add this label, Jlabel, to my window. Okay, I am adding this label to my window. So that's what's going to happen. You make a component, you configure it with its methods, and you add it. And then I make another label here, and I add it to my frame again. But this method is kind of again, it is a label, but it has an icon to it. This is line 28. This is how you load a icon from a file. I load this icon from the file, and I send this one to this Jlabel constructor, and we say that, okay, this label will be, this bug icon will be left oriented, and this is my tooltip text, and I add it. Okay, so this is a way of adding a label with an icon. I am going to do a third label. I make a label, constructor, plain constructor, no parameters. I set it text, I set it as icon, and I said that horizontally you are going to be at the center, vertically you are going to be at the bottom, and your tooltip will be this. So you can play with the positions of the icons as you, the labels as you like. And that will be it. So this class is a class that contains only the constructor. That's it. When you run this program, you only show this much. When you roll over, the labels, you will get this tooltip, and that's it. Very simple, very simple. A little bit more detailed than the previous one, but still very simple window. Okay, as you see, it is very different from what we did before. We used to have a sequence of things. I mean, when the program runs, I ask the user to do something, I get the results from the user, and I perform some task. And I show the result back to the user and maybe ask some more, and then maybe I end my program. Well, in this case, in my main method, I don't do anything like that, okay? I don't ask the user to play with the window. I don't ask the user to do something for me. And I don't end my program myself, okay? I just show my window on the screen, and that's it. After that, I am gone. Okay? After that, I am gone. It is very different from what we did before, but usually this is how the graphical user interfaces are defined. You don't control the sequence of operations yourself. It is up to the user. The user makes that control. Whatever the user needs to do, it does that. Okay? The user can move this window around, can minimize it, maximize it, play with its size, roll over, and etc. Okay? You don't write code for each of them. It is all handled automatically. Okay, good. So what did we do? We looked at this class, JFrame, and for the JFrame, we added 3 components, label components, and we are going to see many other components. Okay, many other components. Okay, good. So this is the object class hierarchy of the GUI classes, and a very, very small part of it. Okay, everything has to be from object. Okay, component, container, and J component. Our components will be J components. We like them because these J components are very small, very fast. They have pluggable look and feel to them. Their appearance is like that because whenever we see them, we call them, okay, we can we can understand what they do. They have common event handling capabilities, and they have tooltips, and they support localization. What is localization? Anybody knows what localization is? Localization. Somebody should know this. Localization is this. When you develop a program, okay, let's say I developed it for the Turkish market, so its interface in Turkish, but I like to sell the same program in for example in USA. So I have to change all the strings to English, and if I like to sell the same program in German, I have to change all the strings to German and etc. And each time I have to modify my program. No, you don't do that. Localization does this. You write your program independent of the language of the interface. Okay. Later, after you are done with your program, you may add your strings, whether they are Turkish or English or German, okay, to your program later. So whenever you need to port your program to some other language, you don't modify your programs, okay? You just change your localization strings. So all of these J components support the localization. That's what localization is. Okay. So JFrame is always, we are going to extend JFrame all the time. Okay, good. And Jlabel is just one component, and we are going to look at the different components in this lecture actually. Okay, good. So let's move on. Let's go to other types of components, and we are going to see some of them in a few minutes. If you go to the documentation of Jlabel or JFrame, you are going to see that, for example, let's go to the definition of Oracle Jlabel. And okay, it comes from the SE7, Standard Edition 7, but that's okay. So this is Jlabel. It comes from Object Component Container, J Component, and Jlabel, as I said before. And let's look at the methods of it. 1, 2, 3, 4, 5, 6, 7, 6. 6 constructors. We use this one. We use this one. And I don't know. I think we use this one too. And these are the methods. As you see, there are many methods available for this Jlabel. And we use the set text, one of them, set horizontal alignment, and etc. These are the methods of Jlabel. Those are good. But Jlabel inherits lots of methods from the J component. You see, each of them are methods that I inherited from J component. Sorry. Okay, so I inherited from container lots of them. I inherited from component, and of course I inherited these from the object. So the label Jlabel seems like a very simple class. Yeah, it is as a class as a simple, but using the inheritance hierarchy, if you use them, okay, it has many details in it, and usually I ignore all of them. I concentrate on this part, okay, on this part of it. Okay, so graphical user interface programming is actually simple to start, very simple, because they hid the complications, all of those complexities away from me. They abstracted away the details. That's the basic ideas of object-oriented programming, right? So using a few lines of code like this one, I can use the Jlabel functionality. If I don't like some of the functionalities, I can modify them, of course. Like Jlabel, JFrame is complicated too, but this is how I use it. I just hid all of those complications by calling this super constructor, and then I am done. Then I am done. Okay. Any questions so far? So today I am going to introduce a number of components like Jlabel, like the buttons, text entry fields, text fields, and after the components, I am going to tell you how to handle events that can occur with these components, such as what should I do when somebody presses this OK button? What should I do when somebody enters a text in the text entry field, and etc. Okay, so those two things I'm going to show you how to do those, and I'm not saying that that's all there is to it, to the graphical user interface programming, but those are the very fundamental things that you do with the graphical user interface programming. Okay, as I said, my purpose here is not to teach you everything about the graphical user interface programming. Okay, JFrame is another class. Okay, default close operation, set size, set visible, etc. We talked about them. Graphical user interface programmings are event driven. What is event driven? Event driven programming is actually a design pattern. It works this way. There is an event loop. It happens. Okay, there is a loop. It gets the event from the operating system, and then I dispatch events. And then I go to the top of the loop. Okay, so when you run a graphical user interface program, this is what happens. There is an infinite loop running somewhere. Now it gets the events and it dispatches the events. Okay, what are the events? Events are mouse movements, mouse clicks, okay, mouse drags, double clicks, keyboard events. When I type something on the keyboard, those are keyboard events. What else? On this computer, I have this touch events, scrolling events, etc. Anything that happens with the graphical user interfaces are called the events. Usually, the events are caused by the user itself, themselves. Okay, the users cause these events. Operating system gets these events. Okay, and it asks your dispatcher of your GUI, tells that, are there anybody interested in this event? Can anybody handle this event? Okay, and if there is somebody handling that event, that component handles the event. That's how the things work. Okay, so graphical user interfaces are event driven, and so what are we going to do? We are going to say that I am adding a component, a OK button. This is my JFrame. I added OK button here, and there are not many things that can happen with an OK button. Okay, maybe somebody can press on it. Okay, maybe somebody can click on it, and after adding this OK button, you tell the system that if this event occurs, if this OK button is pressed, then call this method, and I provide that method. Okay, that's what we mean by event-driven program, and I'm going to show you how to do that in a few minutes. For that one, I will do this text component. Okay, text component is going to show you a text, and let me show you the output of the program first. Very simple. Okay, this is what's going to happen when I run this program. It will show me this window, testing JText field. It will show me 4 text fields, 1, 2, 3, 4. This is an empty text field. Nothing is entered before. I can enter text here. This is another text field. It is already filled in. Enter text here. That text is filled in, but I can modify it if I like. This is another text field. This one is a text field, but it is not editable. It is uneditable text field. Okay, and this is the 4th type of text field. It's called password field. Whatever you typed in this field will not be shown to the user. It is all stars, asterisks, because it's a password field. Okay, if I enter a text and hit enter, then like this one, if I enter a text hello and hit enter, I will get this window. So I am going to do this thing about the event-based programming. I will tell the system that if a text is entered in this window in this field and hit enter, just pop up this dialog window. Okay, remember this is our dialog window and this is information. Do you remember J option pane dialog window? I am going to do that. If somebody enters another text here, okay, I will show this. And if somebody is trying to modify something and hit enter, this is what's going to happen. And here, if I modify something and hit enter, I will get this window. Okay, this is as simple as this one. I will add 4 different text fields and I will assign event handlers to those. That's what I'm going to do. Let me show you the main method again. Main method. Main, again, I am going to make a new text field. Okay, this text field frame is my class. Again, it extends JFrame class, and set default close operation is I am just exiting on close, and this is my size, set visible, and that's it. Basically, we are going to almost do the same thing with all the windows, all the new frames that we are designing. Okay, and now let's go to a text field frame and let's see its definition. It's a very simple 80 lines of code. All of my imports, layout, these are the event-based stuff. Okay, events, JFrame, text field, password field, option pane, etc. But it looks like I am out of time for the first part of the lecture now. Let me take 10 minutes of break. Now we can take 10 minutes of breaks. And let's be here around 10:33. Okay, break 10 minutes. Okay, people, let's look at this program. I am going to make 4 text fields. JPassword field is actually a text field. It extends the class of text field. It's a special text field class because it doesn't show the typed text as the name implies. It's a password. So text field frame is my class name. It extends JFrame, so I immediately call the superclasses constructor. My flow layout is default layout, and this is my text field. Okay, 10 here means my text field will be 10 characters wide. I specify the width of it. Okay, then I just add this text field. That's it. Okay. Another one is a text field. This time I don't specify 10. I specify a text. Okay, enter text here. So this is already filled in text, and I add it. Then I add a new text field. Its predefined text is uneditable text field. It is width is 21, and I set its editable flag to false. Okay, so nobody can edit it. It is a text field. It is used for showing text only. Of course, during runtime, I can change this false to true, false, depending on my needs. But for the constructor, it's going to be false. And then I have this password field. Inside this password field, as I said, it's a text field. It writes hidden text, but this hidden text is not visible, of course. It's a password, and I just add it. Okay, so far I didn't do anything new other than using this text field component. Now I am going to add this. I am going to add this event handling mechanism on top of whatever I did. Okay, this is what I am doing. I am saying that I have a handler, text field handler. Okay, new text field handler. For all the text fields, all 4 of them, I am adding it as an action listener. Okay, this is how you do that kind of stuff. Okay, so we don't know what's going on with this text field handler yet. Let's look at that actually. This is the part where I said, okay, this is the part where you say, if anything happens with this text field, this method will handle it. But I don't see a method here. Method will be inside this text field handler. Okay, so this is my inner class, line 4950. My inner class, private class text field handler. It's a private class. It's an inner class. Okay, and this text field handler implements action listener interface. This is not extends but implements. Okay, action listener is an interface, and inside that interface there is this action performed method. You need to implement this action performed method inside this class. Okay, so if if something happens with my text field 1, text field 2, text field 3, or password field, okay, this method action performed will be called automatically by the graphical user interface system. Okay, graphical user interface manager will call this action performed method automatically. Okay, and when it calls it, it passes this action event as a parameter. Okay, so this is what I am going to implement now. I know that this method is going to be called. So what am I going to do? I am going to do this very simple thing. Okay, I have a string, a local string inside this method. I get this event. Okay, if event source is text field 1, so that means what? Whenever they call this method, this event handling method, if the source is text field 1, then I make a new string.format. Okay, and this string is text field 1 event.getAction command. So event has this method in it too. Okay, so let's look at this one. Events has get source. It tells me the source of the event. Also, event has this string in it. Okay, getAction command. Okay, and I put them together and I make a new string. If my event source is text field 2, I do the same thing, but this time this is different, and field 3 is different. For the password field, okay, I don't use this getAction command, but for the password field, I get the information directly from the password field. And familiar window here, J option pane, show message dialog, and that will be it. Okay, so this is show message dialog, and that will be it. That's end of the class. That's end of the class. So when I run this program, okay, my main ends here, but this window is still being shown. Okay, if I enter hello and hit enter, I get this one. Why? Because if I enter hello and hit enter, okay, this method, action performed method, will be called on that text field 1. Okay, I already added my handler there, one by one. Okay, so this is event-based programming. Of course, you need to tell each of your components that these are your handlers. Okay, and handlers cannot be arbitrary methods. Handlers could be methods like these. Okay, it's a method inside a class. Okay, that class object is handler. I know that this handler is of type action listener. Okay, action listener. Okay, so action listener, if this handler is an action listener, it has to have this action performed method in it, because that's the definition of the interface, right? Interfaces should have methods in them. Okay, and this is how I define this action performed. It takes an event, action event, and inside the action event there are things. What did I say? I used get source and get action command. Let me go to the Oracle documentation. Oracle action event. Okay, let's look at this action event class. Inside this action event, what kind of methods do I have? Okay, get action command. What else? Okay, these come from the AWT event. Get ID, get source. Where is get source? Set source. Where is get source? Get source is from event object. Okay, this is not as complicated as JComponent or JFrame or Jlabel. Okay, but still it has its own hierarchy. So get action command returns the command string associated with action. I get that one. Okay, good. So that's basically it. This is our first program. This is our first program that has components and that has their corresponding event handlers. Event handling is done that way. You define an event handler class. Probably it should be, usually it is an inner class, okay, a private inner class, because other than myself, nobody is going to touch this handler as an object, okay. But this class has to be a special class. Why? Because it has to implement the action listener, okay. Question for you. If I go to this text field, okay, if I go to this text field, JText field, and if I look at the add action listener method of the text field, what do you think the type of this handler is? Tell me the parameter type for this add action listener. What is the parameter type of the add action listener? Anybody? What is the parameter type of the add action listener? I am adding a new text field here. Okay. Text field handler. Text field handler is this. It is not that difficult. Abdullah, are you saying something? Abdullah? Abdullah, talk to me. What are you saying?
Değil de o yüzden yazıyor.
Abdullah, I don't understand what you are saying. Just say it again.
I'm in the library. That's why I'm typing.
I don't understand what you are saying, Abdullah. Anybody? What is the parameter type of the add action listener?
Hocam, is it action listener interface?
Exactly, yeah. It is. Well, we don't say it interface, but it is action listener, just action listener. So this text field one says that, okay, if you need to give me a handler, if you need to register a new method to me as an action listener, it has to be of type action listener. Otherwise, I wouldn't compile, right? Okay, that's why I implemented this. So if I erase, if I just erase this two words, implements an action listener, would this program compile? No. Why? Because line 43 is going to tell me that Okay, I need an action listener for this one. Well, I provide you everything that you need, but the compiler doesn't know that. Okay, compiler needs an action listener for that area. Okay, good. So again, very nice usage of the object-oriented hierarchy inheritance, because I mean I need a handler. Usually in C we do this kind of stuff with the function pointers, but this one would take any type of function pointer, okay, and that wouldn't be nice, sometimes problematic. This one says that I am going to need an method name is going to be action performed, okay, and to make it more standard, okay, make an object of type action listener, and I know that any object of type action listener will contain this action performed in it. An action performed takes an event, and I can ask the event source, I can get the action command from the event, and etc. That's it. So let's look at more examples of components and their event handling mechanism. Okay. So we have nested classes in Java, of course, like in C++. And this one was a non-static nested class. These are my inner classes. And for the event handling, I write those kind of classes. Okay, let's look at our next example. Okay, before we move on, okay, these are the types of events. The event that I looked at is the action event. That's what happens when I type something in a text field. But there are other type of events. For example, what kind of event? Keyboard event, mouse event, okay, window event, paint event, container event, etc. Scrolling event, okay. So I'm not going to look at them one by one, but we are going to check some of them out, okay. For example, this item event happens with the list items. If you have a list box or combo box, it happens there, okay. So let's look at some of the other examples of these events. By the way, these are the listeners, these are the interfaces, okay. So action listener is just one interface. Mouse listener is another interface. So if you need to handle mouse events, you need to implement this mouse listener. And if you need to handle keyboard events, you need to implement this key listener. Okay. And so far we looked at this action listener, which has a simple action performed method in it. Some of these listeners are more complicated, but we are going to see. By complicated, I don't mean it is complicated to understand. I mean it is more involved. It has many other methods defined in it. Okay. So each component in Java, okay, each component in Java has a listener list. This is a list of listeners, okay. When you register an handler, event handler, it is added to the list. If something happens with that component, this list is scanned to find if a handler exists. If a handler exists, that handler is called. Otherwise, that event is ignored. That's what we do. Okay, let's look at this button component. And with the button, there are, of course, its own events, and we are going to see it. Let me show you the program. This is the hierarchy of the buttons. J component, abstract button, as the name implies, this is an abstract button. There is this regular button class, and there is this toggle button class with the check boxes and radio buttons. We are going to see each of them one by one. Let's look at the J button first. Okay, here it is. Okay, I will have this simple window, two buttons, plain button and fancy button. This is a plain button like an OK button. This is a button that has a icon in it. Okay. When I go on and click on this plain button, okay, a new window will pop up and it will say you press plain button. And this one is going to be, the other one is going to be fancy button. Okay, when I click on it, it will be fancy button. That's it. Very simple stuff. But to be able to do this, of course, I need to add these two buttons and I need to register event handlers for those. Let's look at these. Again, very simple main method. I will make a new button frame, which is my class. Close operation, this is the size visible, so this is my main. So let's look at this button frame. Of course, we are extending JFrame. I will have two private buttons. Okay, two private buttons, J buttons. And as usual, call the super class of the JFrame constructor. Set layout. I have my button and play J button is added. And fancy button is added. But for the fancy button, I have the icons, okay? Icon number 1 and icon number 2. And icon number 1 and icon number 2. These are even, I mean, what is the fancy button? Fancy button has an icon on it, but it has two icons. Icon number 1 is for the regular icons. Icon number 2 is the rollover icon. Okay, so I added the bug 1 and bug 2, and that's it. So I have two buttons. So far, nothing new. Now I am going to add handlers to this button. Okay, button handler. Button handler will be a private inner class. Again, this one implements an action listener. Okay, so this action listener, let me get rid of these. Okay, this action listener, again, like the previously, has to have an action performed method in it. This action performed method gets the event and it shows a message dialog, says that, okay, you pressed action command. This action command includes the source of the event that causes this. It is the button itself. So this is the action performed. By the way, remember the show message dialog. Button frame this. What? Button frame this. What is button frame this? Okay, button frame is this one. So bottom frame, this is the, since I am an inner class, right? I am an inner class now. Here. Okay. I'm an inner class. I like to get the reference of my object, but not the object of this class, but the other one. Bottom frame this and string format you pressed, etc. Okay, so this one says that I am connected to this frame. So let me show you this one. Okay, when I press this button, this one will pop up. Okay, this dialog is connected to this window. Okay, if this window dies, this dialog will die too. Okay, it doesn't make any sense to keep this window if this window is dead. That's kind of, this is my parent, it kind of says. Okay, this is my parent, it kind of says, and that's it. So we wrote our, we have seen our second example with component and their listeners, and for both of them we have used this action listener interface. I'm just interested in the action listener, and you might wonder, how should you know about what type of listener I should implement? Well, you are going to read the documentation. You are going to look at the example programs like these. Okay. So example program like this will tell you what kind of things you need to implement. Otherwise, you need to go to the documentation of that button thing. Okay, so add action listener in that case is my method to register it. Let's go to this button documentation, J button, and let's see what kind of listeners I can add to. Okay, let me see. Oracle J button. Okay, this one. Okay. Let me see what kind of things I can. These are the constructors. These are the methods, but the important thing here is do I have add? I have 26 adds. Okay, so good. So I have add action listener, add change listener, add item listener, add ancestor. I don't know what. Okay, maybe I should just listener. Listener, I have 62 listeners. Okay, so add action listener, create item listener, change. So so it looks like action listener, change listener, and item listener are the kinds of listeners that I can add to this J button. We already did that. Let's look at this item listener. Okay. So this item listener, just as a item listener, as the name implies. Let's go to this item listener. Item listener happens. Invokes when an item has been selected or deselected by the user. So if you select this OK button, then this event occurs. If you handle it, you will handle it. Otherwise, it will be ignored. Okay. How do you select an OK button? Let me try to, for example, let me go there. Let me go to my settings. No, it doesn't happen there. So can I do, yeah, okay. Does it work? Yeah, see, when I hit the tab character, I change, I am not using my mouse, okay? Okay, I am using my tab key to select different GUI components on my screen. So this is how you change your button, for example, OK button or any other kind of buttons. So that must be it. So back to our code. This is how you find out what kind of listeners you can register to your components. You have a component, you add it, and just look at the documentation and see what kind of listeners you can have. Okay. In this case, I have action listener for the button. One other possibility is maybe just use comma item listener. Okay. If you implement item listener too, you need to add the corresponding method, whatever it is. Okay. Any questions? Okay, good. Nobody remembers all this kind of stuff. Nobody is going to memorize all these methods of J component. What is the names are kind of logical. When you read the name, you will say that okay, this must be it or this must be etc. But nobody is going to remember all that kind of stuff along with their parameters. Okay, so when you learn about the graphical user interface programming, you learn the main philosophy of it. You learn the main workflow of it. The rest of them is about looking back and going to the documentation. That's why, I mean, I don't like to discuss this as part of Java programming language. It is just in your time, on time, you just read the sample documentation, sample programs, read the documentation, and come up with your own program yourself. Here I am trying to tell you, okay, this is just a design, right? Object-oriented design. How a good object-oriented design can look like, may look like. That's what I'm trying to show you, okay? And this one is using all the aspects of object-oriented programming. Definitely, inheritance is used a lot, of course. And here, this action performed, right? Somebody is calling this action performed. Who is calling the action performed? I am not calling it. So it must be true polymorphism, right? I just add a new method of my own. Some pre-compiled code is calling my method action performed. Okay, so whoever is calling it, whenever they wrote that code did not know about my action performed. I just wrote it and I am just compiling it. Okay, so it is using polymorphism too. Okay, and my class structure, my encapsulation, my principle of information hiding, etc. They are all there. So these are very nice examples of object-oriented programming systems. That's why I like to look at this GUI stuff. Okay, that's it for the buttons. Let's move on and let's try to see some other. Let's remember our button hierarchy. Here is our button hierarchy. I looked at only this one. Let's look at these two: checkbox and radio button. Okay, so just to remind you what the checkbox is, let me show you this. Okay, so this will be my window. I will have one text field, one component, a checkbox button, another checkbox button, two checkbox buttons, and one field. So there will be three components, J components. Okay, and this is what I'm going to do. If somebody clicks on this bold, my text will be bold. If somebody clicks on this italic, my text will be italic. If they click on both of them, it will be both bold and italic. Okay, so I need to handle events, click events on these two checkboxes. Okay, these are checkboxes. And what was the other possibility of the button? Radio buttons. Radio button is going to be okay. So this is a radio button. Okay, so the difference between checkbox and the radio button is if you click on any of them, the other one will be unclicked automatically. Okay, when I click on this one will go away. Okay, when I click on this one, these three will be unset. Okay, so let's look at the checkbox first and we will come back to radio button later. Okay, so checkbox frame, again, main method, very simple. Checkbox frame, my exit stuff, size and true, and that's it. Okay, so let's look at the checkbox frame. That's 60 lines of code. Okay, why don't I just get rid of this stuff? Sometimes they are useful. Is this useful? Maybe. No, I'm going to get rid of it. Okay, good. So this one, I will have, as I said before, these are all of my imports. I will have one text field, two checkboxes. and this is my constructor. I call my constructor of the super, okay, super class, and that's it. What? And then my layout is this. Here's my text field, okay. So my text field already filled, and this is how you set the font of your text field. My font type is this. It's a plain font, and it is a font size 14. You may change your font sizes of your text field like this. How did I know that? I just looked at the documentation and it was like that. Okay, so I fixed my font and it is plain and it is 14. So this font plain can be font bold or italic or bold plus italic. Okay, so what is this? Okay, question for you. What is font? What kind of object-oriented structure is font? What do you think font is? It looks like, yeah, AWT, Abstract Windowing Toolkit, font. What is font? Plain is a final static something. What is font? Just take a guess. Oracle font AWT. Okay. So font is a class. I thought it was an interface, but it's a class. Inside the inside the class, I have these static fields in them. Okay, so modifier static int bold, and I have italic. What else? I have plain. These are all constants, right? Because they are capitalized. How come they are not saying it is a final constant? Modifier type, modifiers and type. Yeah. So font is a class, and inside the class I have these constants. Okay, so it says that I am a plain font. Okay, and size is 14. And what? Okay, so I have two checkboxes, checkbox bold and checkbox italic. Okay, just next to, remember, next to them there is this explanation of the checkboxes, and I added both of them. So I have three adds, 1, 2, 3. One is for the text field, two are for the checkboxes. And of course I have the handler. I added them. Checkbox handler is here. So this one is not action listener, but this one is item listener. Okay, item listeners are different from the action listeners. Item listeners are supposed to implement this item state changed method. Okay, inside item listener there is this method item state change. Okay, okay, so item event, it's not action event, but it's item event. I get the item event, I look at the source of the item event. Okay, if it is bold JBox, this one, then that means what? Somebody has clicked on the bold JBox, okay, bold button, but I don't know if they selected it or deselected it, okay. So I just look at it. Is bold J checkbox is selected? Okay, if it is selected, then my font is bold, otherwise it is plain. So value bold is either bold or plain. Okay, that's a private integer. And then I do the same thing. If the source is italic, again I check italic checkbox is selected. It is either italic or plain. Okay, so value italic. I have two integers here. Okay, value bold, value italic, they are either font italic or font bold or font italic or font plain. Okay, so I obtain this information and I am going to set the text field font to this. Okay, font is going to remain the same, size is going to remain the same. Am I going to be plain or am I going to be bold or very static? It is done this way. What kind of addition is this? Tell me, what kind of addition is this? What are the parameters of this plus operator? What did you say, Barish? Barish, did you say anything?
It looks like font, but it combines the bold and italic. I'm trying to guess, but I don't know.
So what is bold and italic are integers. Value bold and value italic are integers. So this must be a integer addition, right?
Definitely.
So it is an integer addition, but so how does it work? It looks like this. These are all defined. For example, plain is defined as 0. Bold is defined as 1. Italic is defined as 2. What else? Plain, bold, italic, for example, underline, right? Underline is defined as 4. What else? What kind of other things we can we with the fonts? Underline, bold, italic, strike through. You just strike through the letters 8. So what did I do? It is like, let's say I have 8 bits. Okay, this is the bit for the bold, this is the bit for the italic, this is the bit for the underline, this is the bit for the strike, etc. Right? So each one has their own bit. That's why it works. Okay, if value bold and value italic are both plain, 0 plus 0 it makes plain. If value bold is 1 and value italic is 2, 1 plus 2 is 3. So it is, I know that this one is 1 and this one is 1. All of them are, the rest of them are 0. Okay, so it's kind of an OR operation, bitwise OR operation. Okay, so that's how they decided to do it, and this is how they implemented it. Again, it's just a implementation issue, design issue. That's how they implemented this font parameters. Okay, the better thing would have been using a enumeration, but they didn't do it. So it was their decision and we are going to use it. That's it. So another example with a component, a button component, specialized button component, along with their handles. Their handles are this time is not action listeners, but they are item listeners. Okay, for the item listeners, we have the item state change method to be implemented instead of action action listeners. Good. Any questions? Any questions so far? Okay, let's move on then with other components, with other types of components. I am not going to look at the radio button much. It is almost the same thing. The only thing is that you need to group those radio buttons so that if you press one of them, the others will be turned off. So again, radio buttons, 4 of them, and I add the item listeners. Okay, so these are all the item listeners. Radio button handler, item state changed, etc. So I'm going to skip this. Let's look at this combo box. Combo box is this. Let me show you the program output and you are going to do it. Okay, so that's it. There will be a combo box. Okay, you can select, when you press this button, a list will appear and you may select any of them if you like. So if I choose this bug 1, this one will show up. If I do bug 2, this one will show up. If I choose this travel bug, this one will show up. And if I choose this bug animation, this one will show up, etc. So combo box is something like that. It's a drop down kind of a list, and I think this is a combo box, right? Is this a combo box? When I say that, yeah, see, something is popping up. I can select any of them from here. Okay, so this is a combo box, modern combo box if you like. Okay, so let's do that. So I am going to add this combo box to my component, to my JFrame component, okay, as a component, and I am going to register my handler. I am going to register my handler, and my handler will work to do whatever I want with my system. Okay, let's go to the, again, the main is the same thing. Let's go to the code itself. Let me get rid of, I don't think that they will be useful for me. Okay, so that's it. So I have a combo box and a label. Okay, I have a array of strings, and I loaded 4 icons from the disk. This is how you load it. I'm not going to go into the details. Okay, and this is my constructor for the combo box frame. I call the super constructor again, and okay, so this is a array of strings. This is an array of icons. This bug 1 will correspond to this one. Bug 2 will do the, okay, so you know, right? Okay, I'm going to use these arrays to give a name to the icons, and the icons are there too. Okay, this is my constructor, flow layout, and okay, interesting stuff here. Okay, so I added my new combo box with the names. Remember, the names are these 4 of them. So combo box with names, and I am telling the system that just show maximum of 3 names at the same time. For the others, I have to scroll down. Okay, good. What else? Let's ignore this part for now, and I add my combo box, and I make a new label. Remember our labels, but this time I make a label with no text, just an icon number 0, and I add that label. So I add 2 components. One is a combo box, the other one is the label, and okay, this is the label, this is the combo box. Now I need to register my handlers now. Okay, for now I am doing this Java Java feature anonymous inner class. Okay, so I am going to write an inner class, but this inner class doesn't have to have a name because I am not going to use the objects of this inner class in many places. I am going to use this object of this inner class in one place. That's why I don't have to give a name to this inner class actually. I am saying that, okay, this is a new class, this part. Okay, this part is a new class. Well, maybe I shouldn't take this. This part is a new class. This class implements item listener interface. Okay. With the item listener interface, I have item state changed method implemented. And I am making a new object out of this class. New class, and it's a new object. And I add that object to my add item listener. So this type of inner classes are called anonymous inner classes, and in Java it is possible. Okay, you are defining a class without giving a name to a class, and you are making an object of the class. Okay, since this class is a very simple one, okay, it needs to implement this item state changed. So it just says get the event, get state change, item selected. If the get state change is item selected, then I set remember my label? I set the icon of my label to the corresponding element inside my icons. Remember icons? Icons array. Okay. So whatever I selected, I choose the corresponding icon from the icon array. I set it to my label, and that's it. That's it. That's the whole thing. Okay, so that's the whole program. It's very simple. So I didn't have to write it this way. I could have done another private inner class, nested class, but this time I choose to make it an anonymous without giving any name. So it looks kind of weird because we have never seen a class without a name before, not in C++, not in Java. But sometimes we prefer it, especially if you are going to make just a single, just a single object of a class, okay? If you are not going to make many objects of it, why do you have to give a name to it? That's the idea. That's called anonymous inner class. As I said, anonymous inner classes are parts of Java core language itself. They have nothing to do with graphical user interfaces, but usually we use them in specifying these kind of event handlers in graphical user interfaces. Anonymous inner classes, just make a note of it. You might use it from time to time. Okay, any questions so far? It looks like I am out of time for the second part of the lecture. I will have to take some break of 10 minutes. After the break, we will continue, and what are we gonna do? We are going to do something like that. Instead of combo box, it's going to be a list. I will show you this window. Whatever you select from the window, okay, from the list. Okay, if you select blue, I am going to change the background to blue. If you select red, it's going to be red. So it's going to be list instead of combo box. Combo box. Okay, let's take 10 minutes of break. 11:38. We will be here. Nereye gittin? Hani ders çalışıyordun?